Hello, this is Math 2231 coming to you from the College of DuPage for the summer of 2020, and this is the first continuation of the lecture entitled Improper Integrals. When last we left off, you were working on this problem. You were determining for what values of p does the improper integral from 1 to infinity of dx over x to the p converge. And when does it converge, and what is its value? I hope you had a chance to finish this, but if not, you have a chance now. You know what to do. Let's see how you did. Alright, so let's take p not to be equal to 1, and so it's a number, and so this definite integral going up to a number b is going to be this. You add 1 to the exponent, and you divide by the new exponent. You evaluated these. We'll plug those numbers in, and we will get this, and so we will have 1 over 1 minus p. This is 1 over b to the p minus 1 minus 1. So this improper integral is going to be the limit as b goes to infinity of that. Take the limit as b goes to infinity. This part will go to 0 if p is greater than 1. And so that means this is minus 1 times that, and you switch the denominator around and you get that. So that is what we get if p is bigger than 1. If p is less than 1, then this is b to a negative number, which makes it in the numerator, and it becomes infinite. Therefore, the integral converges to this value if p is greater than 1, and it diverges if p is less than 1. Now, you might ask, what happens if p is equal to 1? Well, we actually did this one already, and we found that it diverged. So the answer is it diverges if p is less than or equal to 1, and if p is greater than 1, it converges. Here's another one for you to evaluate. This one goes from minus infinity to infinity of 1 over 1 plus x squared dx. You know what to do. Let's see how you did. Now this is one of them that we need to break up, and we look at the picture of it over here, and we can see that this is an even function, and so that makes us realize that g, it would probably make sense for us to break at 0. So you see this integral from minus infinity to infinity is going to be the sum of the integral from minus infinity to 0 and from 0 to infinity. Now we have to evaluate each of these improper integrals. So let's start with this one. And you might recall, and this is good review for the final exam, that this is the inverse tangent. And so that's the inverse tangent we're evaluating at these points. And the inverse tangent of 0 is 0, but the inverse tangent of as you go to minus infinity is minus pi over 2, and so this answer, that's a minus minus, so that is going to be pi over 2. And when we evaluate the other integral, and we could just take advantage of the fact that this area is equal to this area, but I show it here anyway, but you're going to get pi over 2 for that also. If you add pi over 2 and pi over 2, you get pi. Converges, and the answer is pi. Here is a problem called number 3. You want to determine if this integral is convergent or divergent, and if convergent, find its value. It's the integral from minus infinity this time up to 0, 1 over the square root of 3 minus x dx. You know what to do. Let's see how you did. This is what the graph is, and you can't really tell from the graph what's happening. It really depends on how fast that is dropping, but we have to calculate it then. And so we'll go from minus infinity up to 0. So we will be calculating, we'll make that t, and that's the limit as t goes to infinity. So now we're going to calculate this. Now you have to change your variables here, and so you're going to let u be 3 minus x. That means du is going to be minus dx, and so you have to accommodate that when you do this, and you're adding 1 to the exponent. But when you do that, you're going to get that this is minus 2 square root of 3 minus x. We're evaluating that at 0 and at t. And so when we evaluate it at 0, of course, we'll get minus 2, the square root of 3. And then there's a minus sign. When we evaluate it at t, we put t in and we'll get this. But as t tends to minus infinity, you see this part blows up. So that is this, and so the answer is this one, diverges. Here's another one. You're to determine if this integral is convergent or divergent, and if it is convergent, find its value. So we're going from minus infinity to infinity, x e to the minus x squared dx. You know what to do. Let's see how you did. Again, the picture gives us some incentive to look at it. We see parts of it are negative and parts of it are positive, and we're motivated to think about breaking at 0 to see what happens. And that's where we will break it. So we have this infinite integral is equal to the integral from minus infinity to 0 plus the integral from 0 to infinity, and we look at each one of these. So we look at the one going from minus infinity to 0. We can do a U-Substitution on this, and we get still the limit as t tends to minus infinity of this expression. We plug in the numbers and we get this. And what happens when t tends to minus infinity? What happens is e to the minus t squared tends to 0. And so you get minus 1/2. So this first integral is convergent. This does not mean that the second one is also convergent. We have to look at that one as well. And so we do this one. Some similar things happen, except the t goes to positive infinity. And we get 1/2. So the integral is convergent. And in fact, the answer is 0. You see the positive and the negative integrals cancel out. The areas cancel. Here's another one. This is to determine if the following integral is convergent or divergent. If it is convergent, find its value. You're integrating from minus 2 to infinity, the sine of x dx. You know what to do. Let's see how you do. Now the picture again will give us insight as to what happened. We're going from minus 2 all the way to infinity. So we can see that this oscillates in this way. Gives us a little bit of insight, but now what we're going to do is calculate it. So first we change it into a limit. Its limit as t tends to infinity of minus 2 to t sine of x dx. We do this integral. Again, this is good review for the final exam. This is minus cosine of x evaluated at t and minus 2. Now the cosine of 2 is just a number. That's the cosine of 2 radians. So that's just a number. And you subtract this off. But as t tends to infinity, you see this never really gets close to and stays close to a number. It oscillates between 0 and 1. So this limit does not exist. So the integral is divergent. We will continue this discussion in 41.2.